Okay, so let me just give a demonstration of basic BJT biasing. So we just have to make the following assumption that VB, which is the base voltage, is about 4 volts, and so I want to find first VE. Right? I know that VBE is equal to 0.7. We also assume that, which is equal to VB minus VE, right? VB minus VE. And so this entails that my VE is basically VB minus VBE, and this entails it should be that it should be minus 0.7, 4 minus 0.7, which is 3.3 volts. 3.3 volts. So the voltage at this node is 3.3. And now that means I can find out what the current going down this way is, which is my IE. And so my IE should basically we use Ohm's law, so it should be VE minus ground and divided by the emitter resistance. This emitter resistance right there. Okay, times 10 to the power 3, which should be 3.3 over 3.3 times 10 to the minus 3, right? Negative exponent, so that's 1 milliamp. Basically, this is milli. And proceeding further. Okay, what's my next step? My next step is to find what IC is, since I already have IE. Okay, so let's go. So I know that IC is related to emitter current by this relation, where alpha is equal to beta over beta plus 1, and beta is basically the current gain, or the common emitter current gain. And in this particular case, we will make the assumption that it's 100. So that means it should be 100 over 101, adding 1 to beta, right? Multiplied by the current we had earlier, 1 times 10 to the minus 3, or 1 milliamp. That should be IC, which should be about 0.99 milliamps. Right, perfect. All right, now that I have IC, what's the voltage at this node? This is VC. That's what we want to find now. So let us see. So VC, according to Ohm's law, should be 10 minus VC. 10 minus VC divided by this resistance should give you my IC going down. So we have to use Ohm's law again to find VC. And of course, Ohm's law. So V is equal to, excuse me, my bad. So VCC, which is the power supply, minus VC over RC should equal to IC. Right? Ohm's law. But what do we want? We want VC. So that means VC should equal to VCC minus ICRC. VCC minus ICRC. And we already have all these quantities. These quantities are known. Just looking back, 10 volts is VCC. 4.7 kilo ohms is the resistance. And my IC is already known to be 0.99 milliamps. Therefore, just to write this down. Okay, 0.99 times 10 to the minus 3. And then 4.7 times 10 to the power of 3. These two cancel. And we just have to use a calculator now. Let's see, 10 minus 0.99 times 4.7. Okay, I get 5.347 is equal to VC. And of course, now I have to figure out if this is in saturation or in active mode or cutoff. And to determine this, we have to figure out what VCE is. VCE, as the name implies, is VC minus VE. know what VC is, I know what VE is, and so I should just go 5.347. 5.3.7 minus, we said 3.3 volts, right? Minus 3.3 volts should equal to 2 volts. And all this entails that this is in active mode, right? Because VCE is greater than 0.3 volts. This means that this is in active mode and not in saturation, and therefore we can assume that these values are correct. VCE is 5.347 volts. Our collector current is 0.99 milliamps. Our emitter current is 1 milliamp, and our emitter voltage is this. Yeah, I think this should be good enough. That should be sufficient to demonstrate the very basics.